Hello, everyone. My name is Florina Muntenescu, and I'm a developer advocate at Google. Earlier this year, at Google I/O, we announced in alpha the architecture components, a set of libraries that allow you to design robust, testable, and maintainable apps. And now, the architecture components are finally in 1.0, and they are ready to be integrated in your own production applications. Today, I want to tell you a bit about the architecture components, and I want to give you a set of best practices, just to make sure that what you're doing is on the right track with the components. And also, I want to tell you a few things about one of the newest additions of the components, the paging library, which is still in alpha. So let's start with the architecture components. We'll go over each of them. So let's say that this is an activity that displays information about the user. One of the biggest problems is configuration change, because this is when the activity gets destroyed and then recreated. This is why in the architecture components, we created the concept of lifecycle and of lifecycle owner. So an activity or a fragment has a lifecycle. Therefore, they are a lifecycle owner. The lifecycle of a lifecycle owner can be observed by a lifecycle observer. And you can implement your own lifecycle observer and define methods that will be called whenever a specific lifecycle event is triggered. So, for example, if you want to start something like a location listener, you can just define a start method for it and annotate that method with @lifecycle event and the event that you're interested in, for example, onStart. And then this will be triggered whenever onStart will be called. Like this, we can create components that are lifecycle aware. Architecture components provides one of these lifecycle aware components. This is live data. Live data is actually a data holder. And other components can set the value of the data that's being held, and activities and fragments can observe that live data. And they can react on it and update the UI. But when the activity is on pause or on destroy, the subscriber is removed. The live data is considered inactive, so the events are not propagated. But when the activity is recreated, we subscribe again, and then the UI can again react on the changes of the live data. So the class designed to store and manage UI data so it survives configuration changes is the ViewModel. And this is the lifecycle of a ViewModel compared to the lifecycle of an activity. So what's important here to notice is that whenever the activity is finished, the ViewModel is cleared, so only then. So this means that the ViewModel will survive configuration changes, but it will not survive pressing back, killing the activity, the application from recents, or when the framework kills your app. So this means that when long-running operations finish, the ViewModel is updated independent on whether the data is observed or not. So this means that you will no longer get null pointer exceptions when you're trying to update a non-existing view. So you should avoid references in the ViewModel, because these can lead to memory leaks or crashes. So instead of pushing data to the UI observes the ViewModel. So make sure you don't hold any UI logic in the view, but rather you move this in the ViewModel so it can easily be unit tested. So, for example, it will be the ViewModel's responsibility to get the user, prepare it for it to be displayed, and then, if needed, hold it for the UI. And then the UI would notify the ViewModel about the user's actions. The ViewModel works with a repository to get and set the data. And repository modules are responsible for handling data operations. They provide a clean API to the rest of the application. They know where to get the data from, what API calls to make, and when the data is updated. So you can consider them as mediators between different data sources. It's a good idea to have a data layer in your application completely unaware of the presentation layer. The thing is that algorithms that synchronize and keep cache and database in sync with the network are not trivial. So adding a single point of entry that deals with this is recommended. So the repository would know what call to call, what API call to use to get the user. And because we want to make sure that we're not doing more network requests than needed, we will also save that in a database locally. To save the data locally, architecture components comes up with a new library, Room. Room is a wrapper over SQLite database, an object mapping library that provides data persistence with minimal boilerplate code. So our table, our user's table, will look something like this. We would have a user ID, name, and some other user information. And what we want is to save the users in such a table, and then every row is an instance of the user object. To do this, we define our user object, and we just annotate it with @entity. We define what are the columns of this user by using @column_info, and which one is or are primary keys. To actually access the database and work with the data there, we use the data access objects. So we create an interface or an abstract class, we annotate it with DAO, and then there we define the methods that work with our database. These can be query, insert, update, and delete. Queries can also return live data objects, making this query an observable query. So what's an observable query? Let's say that our users table looks like this. So we have two users with ID 3 and with ID 4. But what we're interested in is getting the user with ID 4. So initially, our live data will emit John, because we want the name for it. And then, when we update the table, and then we update the user with ID 4, and instead of John, we set the username as Mark, our live data will automatically emit Mark, the new user. Room also supports Flowable if you're working with RxJava. So usually, developers that use RxJava in their application tend to use it throughout the entire layers. So starting from the repository to the ViewModel to the UI. So one thing that you could do is use the live data only on the UI layer. So live data was made for the UI. So leverage that connection to the activity lifecycle. To help with this transition between live data and RxJava, you can use the live data reactive stream class. This provides two methods from publisher that allows you to create the live data from an RxJava stream, and to publisher that allows you to create an RxJava stream from a live data. So using the observable queries means that we can have a UI that reflects the latest changes in the database. And then the ViewModel propagates the changes in the repository to the UI. Like this, we have a high degree of testability and a separation of concerns. What we're showing here is actually the guide to app architecture. It's the way that we suggest that you could architect your application so you can have all of these properties. Let's talk about saving the data. Let's say that we want to save the data that we display on the UI. Where should this be saved? In SavedInstanceState, in the ViewModel, or in the database? So one thing that we should really remember is the ViewModel survives configuration changes, but not pressing back, killing the app from recent, or when the framework kills your app. So when we're creating an activity, this is what happens. OnCreate gets called, then the ViewModel gets created, the ViewModel works with the repository gets the user from the API, and then saves the user in the database. And then the ViewModel creates this user UI model, a POJO class that we would use to display data on the UI. So let's go over a few scenarios. The first one is configuration change. So let's see what happens. In configuration change, the onStop method is being called. And then onStart is being called. So here in onStart, we would just display the user UI model from the ViewModel. We don't need to do any calls to the repository or to the network. Scenario 2. The app goes to background, and then the user navigates back to the application. So when the activity goes to background, then the onSavedInstanceState is called. And then when the activity comes to foreground again, we can just display the user UI model from the data from the ViewModel. Again, we don't need to call the repository. We don't need to do any network requests. But scenario 3, the most interesting one, when the app goes to background and the process is killed. Well, in this case, when the activity goes to background, onSavedInstanceState is called. So this is the place where we can save the user ID of our user. And then the activity gets killed. And then when activity starts again, in the onCreate, in the bundle, we have this user ID that we've saved before. So based on this user ID, we can pass that to the ViewModel. And then the ViewModel gets the user from the repository based on that user ID. So this means that we don't need to do any network requests if we save the user ID in onSavedInstanceState. So in the end, what should you put in each of them? What should you put in onSavedInstanceState, in the ViewModel, or in the database? Well, keep in mind that in the database, you should put the data that survives process death. So this is where you should put your user object, the big one that you have. Then, in the ViewModel, you should put the data needed for the UI. So for example, that user UI model that you use to display on the screen. And then, in onSavedInstanceState, you should put the minimal amount of data that allows you to restore the data. So for example, a list of IDs. But instead of one user, let's consider that we have a list of users. Many applications need to load a lot of information from the database. But database queries can take a long time to run and use a lot of memory. And we have a new library, the paging one, that makes it easy to load the information gradually. So for now, the architecture components is still in alpha. And what I'm going to tell you is not live yet. It's only going to be released in the next version of the alpha of the paging library. So the app starts. The ViewModel for the screen is created. The view subscribes to the notifications of the data. The ViewModel works with the repository and is subscribing to the data coming from it. And then the repository works with the data source. Nothing new so far. So we have the data coming from the data source to the repository, then to the ViewModel that changes the data, preparing it to be displayed on the UI. And then the ViewModel gives that data to the UI. So let's say that in the UI we have a recycler view. And that recycler view would work with a recycler view adapter. So that data would go to the adapter, and only then the adapter will notify the UI and will display the list on the screen. So this means that the advantage of this architecture is that the data source is completely separated from the UI. And then the UI just observes the data. And we can have one data source and recycler views. We can easily reuse the same UI logic, the same data source logic in different UIs. And then the paging library will actually be used throughout this entire architecture. The objects that all of these classes have in common is a page list. And then instead of a recycler view adapter, you would use a page list adapter, which just extends from a recycler view adapter and uses a page list. So let's see more what's going on there. We said that we have these main components. So what's a page list? A page list is a lazy loading list that pages content from a data source in chunks. It supports both infinite scrolling lists, but also countable lists. Creating a paging list automatically triggers loading of the data from the data source. And this is why it should be done on a background thread. And this is the reason why the paging library is using live data, because live data ensures that whatever operation is done to request the data from the data source is done on the background thread. And then, once the data is constructed, then it can be passed to the UI on the UI thread. So let's say that as a data source, we have for now a database. The data source gets the data for the page list from network or database. Then the data is put in the page list. And then the page list adapter works with the page list and updates the UI. What happens when the user scrolls? Well, at this moment, the page list requests the next page from the data source. The data source gives the next page, and then the page list adapter updates the UI. But let's say that the user swipes away an item. So this means that the corresponding item in the database gets to be removed. So the database is updated, the item is removed. But because the source was updated, the data source is invalidated. And this leads to the destruction of the source and the recreation of the data source with a page list. So what's important to remember is that several types of operations can lead to an invalidation of the data source. So if you're doing an insert, an update, or a delete in a data source, then that should trigger an invalidation of the data source, and then to the recreation of the page list. And then this new page list will be populated with the data from the data source. But then the contents of the two page lists are compared in a diffutil on a background thread. And then the diffutil will tell the adapter what changed, and then based on this, only now, the adapter collapses the missing row. So you can use as data source, a database, network, Firebase, file, whatever you want. But you'll need to define how that data is requested. So for this, we have two different types of data sources. The first one is the keyed data source. You would use this one if you need the element n-1 to get the element n. Because of the key from the element, because based on the key from element n-1, you'd be able to get the next one. So for example, when you're working with a data ordered based on a certain criteria. So when you need to get the users by name ordered. So when you're implementing your keyed data source, you will need to define an initial load, and then how to load after the current item or before, if the scrolling up is allowed. So all of these would be based on a key. This key is something that you would define. In our case, for the user, this key would be the name of the user, because this is how we are ordering our list. Another type of data source is the positional data source. So if you are using a fixed item count just based on the position information, you would use this positional data source. When you're implementing a positional data source, you need to implement a load initial and then a load range. And this would be the point where you would be requesting some data from your backend. So when the data is received, you would inform the data source via the load callback. So the next step is to implement the data source factory that can create a data source. And this is needed because when the data source is invalidated, the factory is actually the one that knows how to recreate a data source. If your data source is actually room, then just update your DAO to return a data source factory, where the key, at least for now, is always integer. Under the hood, in the implementation of the DAO, room will create the data source factory for you. But how do you know when to trigger these data requests? How do you know when the user scrolled and that then it's the time to get the data from the network? Well, for this, you would use the page list boundary callback. In the boundary callback implementation, this callback signals when a page list has reached the end of an available data, and this is actually the point where you trigger more requests from the database. So whether you should request items from the front or from the end of the list. And then, to actually get the live data of a page list that ends up being used by the UI, we need to create an instance of the live page list builder. So this gets as a parameter, let's say, the network data source factory, and then a page size, so like how many items should be in a page. And then you can set the boundary callback. I was showing earlier this slide, and I was saying that the diffutil compares the content of the two page lists. But Paging Library wants to optimize this. And instead of comparing two lists, it knows how to compare elements. Well, it knows if you tell it how to compare elements. More precisely, you will need to implement a diff callback between two elements. And you will implement two methods. Are content the same? And are items the same? And then, in your adapter, you would extend the page list adapter of your model and the view holder. You would use as a parameter in the constructor the diff callback that you've just created. And then you just bind your view holder to the item. In your activity, you need to make sure that it extends app-compat activity, so it has a life cycle. And then in the onCreate method, you would create an instance of your adapter, and then you would observe the changes of the live data of a page list from your view model. And then whenever that live data emits, you will set the new list to the adapter. So now we have a list. The architecture components have a high usability also because of Vue, because of all the feedback that we've received on it. So check out the paging library and give us feedback. Tell us what works, what not. Tell us where you would need more things to be done by the library instead of being you the ones that have to implement it. So we had a lot of new concepts and components. We have lifecycle, live data, page list, view model, we have room. But the thing is that you can use them separately. You can pick and choose the ones that you need for your application. Or, if you want, you can use all of them together. Check it out, and let me know how it went. Thank you.